Hello students, welcome to Study It Out. This question is from Physics, chapter Nuclei. In the question, we have to obtain the binding energy in mega electron volt of the nitrogen nucleus, where the mass of the nitrogen nucleus is given 14.00307 U. So this we consider as the experimental value of a mass. So what is the theoretical value? We will solve it shortly. So to find this binding energy, we are going to use the formula EB. EB is the representation of binding energy is equal to delta M into C square. This delta M represents mass defect. And C is the speed of light. Its value is 3 into 10 to the power 8 meter per second. This is speed of light. Now, what is mass defect? So, let's understand if you have nitrogen, this is the symbolic representation of nitrogen. So, this 14 is the atomic mass or the mass number represented as A. 7 is the atomic number, it's represented as Z. So, we know that atomic mass is nothing but the number of protons plus number of neutrons, and atomic number is equal to number of proton. This mass defect is actually total mass of a nucleus, which is calculated theoretically minus the mass of the nucleus calculated experimentally. If we represent this m dash as experimental value, and this we represent it as theoretical value. So we have to find this m value first, because m dash is already given in the question. This is our m dash value. So how to find this m value or the theoretical value of the nucleus? So for that, we need to first find the number of protons and neutrons. So we know that with respect to Z, its value is 7 and it is equal to Np. So number of proton is 7. Now what about the number of neutrons? It's equal to A minus Np. A is given as 14 minus 7. It's equal to 7. So number of neutron is 7 and number of proton is 7. So if we have to find the mass of the nucleus, it is equal to the mass of proton into number of proton plus mass of neutron into number of neutron. By this relation, we can find the theoretical value. So mass of proton, Mp, its value is 1.007825 U, and mass of neutron is 1.008665 U. So let's substitute the value. 1.007825 into number of proton is 7 plus 1.00865 into number of neutron is 7. Now total mass is equal to 7.054775 plus 7.060655. So theoretical mass of the nucleus is 14.11543 U. So we got the theoretical value of M, and experimental we already know that. So both now the values we got it. So can we find the value of delta M here? So delta M is equal to 14.11543, its value of M, minus M dash is given as 14.00307. So we substitute 14.00307. So after subtraction, this value is equal to 0.11236 U. So now we have to find the binding energy. So we got the value of delta M and we substitute in the formula. So here we just write it, EB is equal to delta M into C square. So our delta M is 0.11236 U into C square. So there is a conversion of U and the energy. What is that conversion? 1 U is equal to 931.5 MeV by C square. Based on this conversion, we can solve this problem easily. So here EV is equal to 0.11236 and U value is 931.5 MeV by C square into C square. So this C square and C square gets cancelled. So further solving, we can write it EB is equal to 104.66 MeV. So this is the answer of this question. If you have any question, any doubt, you can write it in the comment box. I will try to resolve it. Thank you so much.